Okay, let's do a quick problem here that has us using our new knowledge of what friction is, or what this mu is. This is my, let's say that's my static coefficient of friction. Remember, coefficient of friction is really the force of friction divided by the normal force, or the force of friction is equal to the coefficient of friction times the normal force, however you want to remember it. So in this case, these two surfaces, remember it's dependent just on the surfaces, it's 0.25. So let's do a free body diagram and see if now we can actually say what all these forces are. So start with a giant force of gravity. Force of gravity is 100 newtons. Go ahead and do my angle here. Rotate my axis based on the ramp. I now know that my force of gravity into the ramp, my FGY, will be there. Force of gravity down the ramp, FGX is there. It's also, I could also have drawn this one up here. I'm not going to do that because that gets confusing. But I know that this is theta, and then I know that the normal force is equal to the normal force will be the same as FGY, and the force of friction will be one of two things. It will either be equal to the force of gravity in the y-x direction, or if we're at our maximum angle, it would be equal to this value right here. So let's just do some numbers here and see what I get. Real quickly, using trig, I know that if my angle here is 20, FGX is opposite that 20, so I'm going to use the sine function. So FGX is equal to FG, which is 100, times sine of 20. FGY then is equal to 100 cosine 20. So now I've done my little calculation here, and these two numbers, those are my FGX, FGY. So FGX is 34.2, FGY 93.9. That means the normal force is 93.9. And that means we can now calculate one more thing using this equation up here. What is the maximum static force of friction? Well, it's going to be equal to 0.25 times 93.9, which turns out, I believe, to be actually 23.4 newtons, or 23.5 newtons. So now we have a bit of a conundrum, because it turns out that this number here, the force of friction, is 23.4. That's a force of static friction, which means it is not sitting still. It means that this has exceeded this. When I place the block on here like it is drawn, it's going to accelerate in that direction. And it's going to accelerate quickly because, let's also not forget, this is our static force of friction. Once it's moving, there's a whole other kinetic force of friction that maybe is something smaller. Let's say the kinetic force of friction, or coefficient of friction, is 0.2. That actually means that now there's even less resistance and it would accelerate even greater.